Hello everyone, so today I'm going to solve a very unique question on limits. The question is, if f of theta is given as this function in the terms of tan theta, the question is, find the left hand limit of f of theta as theta is tending towards pi by 2. So first of all, if you want to calculate the left hand limit, I'm going to use pi by 2 negative. Now here I'm going to take a substitution, that is x is equal to tan theta. The reason I'll tell you. As theta is tending towards pi by 2 negative, I think you can tell me tan theta will be tending towards positive infinity, because it will be easily visible from the graph as you take pi by 2 negative. Then the value of the function will be tending towards infinity. Similarly, if tan theta is tending towards plus infinity, x will be tending towards plus infinity. Now, the reason being I'm taking this substitution is, first of all, the expression will become very easy. And when we have x is tending towards infinity, we have a lot of flexibility. Let's say our limit is infinity by infinity or 0 by 0. We can apply L'Hopital or we can apply binomial. There are many things we can do with infinity. Now, I'm going to write this limit x is tending towards infinity. And I'm going to write the whole expression, that is 1 upon x raised to power 9, whole thing multiplied by, you can write 1 plus x whole raised to power 10 plus 2 plus x whole raised to power 10 plus 3 plus x whole raised to power 10 and so on till plus 20 plus x whole raised to power 10 minus, you will get 20. Here it's power 10, sorry, it's a just mistake in the question. That is x raised to power 10 here. Now we have limit x is tending towards positive infinity. Now I'm going to do one thing here, that is I'm going to take this 20 terms and I'm going to club this 20 terms as in summation format. Now we'll get 1 upon x raised to power 9 here. We'll get summation. You can easily generalize the term. See, 1 plus x, 2 plus x and 3 plus x. So immediately I can write this as r plus x whole raised to power 10, and here r is varying from 1 to 20. Minus, you can immediately write 20 x raised to power 10. Now one more step, that is x is tending towards infinity. Only manipulation is there, okay? As such, I'm not going to do a big thing here. Now what I'm going to do here is I'm going to take the summation, whole summation outside. So if you take the whole summation outside, which is r is varying from 1 to 20, I can write the whole expression as r plus x whole raised to power 10 minus. See, if I add this 20 times, 1 plus 1 plus 1, 20, we'll get x raised to power minus 20 x raised to power 10. So I can keep minus x raised to power 10 because the moment I apply summation, we'll get 20 terms like this. And whole thing is divided by x raised to power 9 here. Now let's do one thing. Let's open this expression using binomial expansion. So we'll get limit x is tending towards plus positive infinity, summation as it is. Now I'm going to open all the terms. So first term is 10c 0. Immediately after opening, I'm going to divide by x raised to power 9. So there will be no one more step. So we'll get r raised to power 0, x raised to power 10. So only one x is remaining here, plus 10c1 r, x raised to power 9 and x raised to power 9 will cancel out, plus 10c2 r square. Here we'll get x raised to power 8, denominator is x raised to power 9. So one x is remaining here. Plus similarly, all the terms will be containing x in the denominator. As you can see, the next term will be 10c3 r cube upon x square and so on. And in the end, the last term is minus x raised to power 10 here. Now, the two terms will cancel out here because 10c0 is 1, plus x and minus x immediately will cancel out here. Sorry, this was power 10 here. So these two terms will cancel out immediately. One more thing, one more mistake I've done here. The moment I'm going to divide, so only x will be remaining here. So minus x and plus x will cancel out here. Sorry. Now only these terms are remaining. Let's do one thing. Here we can make a change here. We can throw summation outside and we can throw limit inside. So the value will not going to change. If I apply limit first, then take the summation. This is very important step here. So in the next page, I'm going to do that. Now here we have interchanged the position of limit and summation. So first I'm going to evaluate the limit, then I'm going to take the summation. So the whole value is not going to change. So as limit x is tending towards infinity, see, the first term is fine if you take the summation. The second term, let's talk about the second term, that is 10c2 r square. So if you take the summation, numerator will be a finite value. Finite upon infinity, I think this term, whole thing will be 0. Similarly, the next term, the numerator is finite, but the denominator is tending towards infinity. So it will be tending towards 0. Similarly, rest of the terms, which is containing x in the denominator, will be tending towards 0. So we are left with, now the limit part is done, we are left with summation. R is varying from 1 to 20. Here we'll get 10C1. 10C1 is 10 and multiplied by R. So 10 if I throw outside, and then summation of R is n into n plus 1 divided by 2, where n is number of terms, that is 20 here. So if I put 20 here, we'll get 10 into 20 and then multiplied by 21 divided by 2. So I think these two will cancel out and give me 10. So answer is 2100. So the value of this limit, left hand limit, will be equal to 2100. So this will be our final answer, and that will be all.